is always the same, and here's what your goal is. Your goal is to prove that triangles are congruent. That's it. So it makes it a little bit easier because you know exactly what you have to do. Now, in these notes, it's really nice because they told you which shortcut to use. The hard part after the notes is that you don't necessarily know what you have to use. You have to figure it out, like we've been doing in that checkpoint. Yes? Okay, so before we get started, I need you to write 4 words on this. I need you to write the word I need you to write can. Okay, so I should see everyone's pencil in their hand. And I should see you writing what I'm writing. I can do, what do you think it's going to say? This. You can do this. Okay? 3rd period is another geometry class. And they were like, oh, this isn't bad. Okay? Like, even they were like, I got this. Now, it was awesome, okay? So, I know y'all can do it too. So, if you open your book, or your little packet, if it comes unstapled, I didn't plan for yours to come unstapled. We'll just restaple it, okay? Don't get your feelings hurt. We are using side, side, side for all of these. So, for these 2 only, we're using side, side, side. So, let's start. First of all, remember, we're using side, side, side. Okay? So, remember, we always start our proofs with what? Given. Now, in these proofs, they have purposely given you enough room to put each given on a different step. So, write RP is congruent to PS, and then below it, you have enough room to write RQ is congruent to QS. Okay, so let's go mark those. So you see RP. Okay, let's put 1 dash on RP and 1 dash on PS. Okay, let's put 2 dashes on RQ and 2 dashes on QS. So remember yesterday when we wrote, like, beside on the activity, we wrote side, 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 and those were our 3 sides? Let's do that here so you know that you have everything taken care of. This is your side. This is another side. But what are we missing? A 3rd side. Do you see it? Yes, it's in the middle. Remember, I've been telling you to put an X on here. That's for a reason. Because if you put an X here, the reasoning behind that is reflexive. So that's what goes here. By the reflexive property, what's congruent to what? What, Asia? PQ is congruent to PQ. Is that my 3rd side? Yeah, so I'm going to put another S right here. I wanted to use side, side, side. Okay, well, there's side, side, and side. So, because of the side, side, side shortcut, we can say, and remember, what you're proving is right here. And that's always your last step. So, triangle RPQ is congruent to triangle SPQ. That's it. Every time. Now, it changes a little bit, but the process is the same. Okay, so let's go try the second one. We're still using what shortcut? Side, side, side. Okay, so let's go ahead and set it up. What goes in 1 and 2? Given. So I'm going to write B is the midpoint here. Midpoint of AC. And AD is congruent to CD here. So the only thing they have flat out told me for sure is that AD is congruent to CD. That's it. And what I mean for sure is that they literally wrote this is equal to this. So that is a side. Now they told me B is the midpoint, but they didn't write it saying it's congruent. So if they didn't write it saying it's congruent, then we have to write it. Okay? Let's see. Grant, tell me what midpoint means.
It's in the middle of A and C.
Right. So if B is right in the middle of AC, then that means this is congruent to this. So how would I write that? Peyton, tell me how would I write this is congruent to this? Careful. Yeah, AB is congruent to CB. Okay, good. So AB is congruent to CB. Well, what's the word that told me that was true? Midpoint. So you're going to use definition of midpoint. Now, would it be silly of me to write definition of bisector if it says the word midpoint? Yes. Okay. All right, so this is my second side. Let's put another side beside it. 2 down. How many to go? 1. Well, that's it. That's all I'm giving. Can I pack up and go home?
No.
No. Do you want to pack up and go home? Yes. But we can't. We can't. We got a shortcut. Cardell, what do you see?
I see, okay, no, I got it.
Okay.
DB?
Well, yeah, DB. What do I put on it? Remember, we've been putting something on it if it's on both sides. An X. Good. Good. So DB is congruent to what? DB by reflexive. Nice job. Yes. Yes. Okay, good. That is a great question. Let me finish this and then I'll explain that. Side, side, side. So, triangle ABD is congruent to triangle CBD. Okay, great question. So, he asked, is it okay if I put reflexive then definition of midpoint? Absolutely. So, your given always goes first most of the time, and this is always last. But if you flipped these on a test, I would not count you wrong. It does not matter what order you put them in. Okay? Your test on this is probably going to be the Wednesday after Thanksgiving, and there's 4 proofs on it. Okay, like this is like the chunk of your test, because this is one whole section, and there's only 3 sections on your test, so this is a third of your test. Yes?
Why couldn't you do AB's congruent to BC?
Because we started with A and went to the middle, so we have to start on the outside and go to the middle. Okay, what are we going to next? SAS, SAS, okay? So, from here on out, or on these 2, we're using S, A, and S. So, I'm not looking for 3 sides. I'm looking for 2 sides and an angle. Are y'all with me so far? Is this better than Chapter 2? This is how it stays the whole time. This is our goal. Every single time we end with a shortcut. Okay? So, let's go ahead and write what's given. How many lines are you going to take up? 2. Does it help knowing how many steps you have to take? How many, for sure, set in stone, this is equal to this, do we have? For sure, 1. WX is congruent to XY. So that's this is congruent to this. Okay, well, let me pick on somebody. Courtney, what does bisect mean? Right down the middle. Okay, so would you use the definition of midpoint if you see the word bisect? No, this is a huge hint. whatever word it says, you're probably going to use that word over here. Okay? So XZ, do you see XZ? Put your finger on XZ. It bisects angle WXY. Here's W, here's X, here's Y. So it bisects this angle right here. So that means this half is congruent to this half. Do you think I'm going to have to write what I just did? Yes. So you have to write this angle is congruent to this angle. But be careful. You can't just write X is congruent to X. Why? There's two parts to this angle. Okay? So here's how we write it. Angle WXZ is congruent to angle. Okay, well, if I use WXZ, how do I say this angle? YXZ. Good. The reasoning, well, it said it bisects, so definition of bisect. So let's label what we have so far. Is step 2 a side or an angle? It's a side. What's step 3? Angle. So what do I have left? One side. Presley, do you see a side that we could assume is congruent? What side do you see? Down the middle. XZ. So you can put an X here. But Jake, because I'm using an X, what word am I going to use for the reasoning? Reflexive. Good. Savannah, how would you name this line right here? Try again. Not Y. This not over here. XZ. Good. XZ is congruent to XZ. Well, there's my third side. Are we done? Can we use those over here? So, by side, angle, side, these two triangles are congruent. Triangle WZX is congruent to triangle YZX. All right, let's keep going. Practice makes perfect. How many steps am I going to take up with number 4's given? Question. Well, this right here, this triangle, I don't mind, but I'm just telling you so you know. This right here is always the same as that. Because when you're done proving, this is your whole goal. That's what you want to prove. So it always has to be your last step. Okay? All right. How many steps are we taking up with this given? Just one. Here's how I know there's not a comma. It's one statement. Okay, let's write this down. Let's go. Pencil's moving. Okay, so am I going to have to use definition of midpoint? Yes. Not only once, but how many times? Why? Because it is the middle of two different segments. Okay? So, if M is the midpoint of LP, that means this is congruent to this. Okay? Sydney, how do I say this? What is congruent to what? Good. PM. LM is congruent to PM. Well, why doesn't she say MP? Well, if you start at L, that's on the outside, and then you go to the middle. Start on the outside, go to the middle. So, what's the reasoning behind this, class? Midpoint. Good. Definition of midpoint. Okay, well, let's just go ahead and do it again for the other one. M is the midpoint of NO. So, JoJo, how do I say that these two are congruent? How do I write it? Say that again. NM is congruent to? Good. NM is congruent to OM. Okay, what is 2 and 3? Are they sides or angles?
Miss Jenkins,
Yes.
can we have Parker Jordan to check out, please?
Yes, ma'am.
Thank you.
Are they sides or angles? Sides. Let's put an S beside it and circle it. Okay? Well, what am I missing if I want to use SAS? Angle. They don't tell me anything about an angle. But what do you see? Good, Peyton. Good, Jacob. Jacob said M, but Peyton said vertical angles. Yes. This is congruent to this. They're vertical. So, what's the reasoning you think I'm about to write? Vertical. Vertical. Vertical angles. Here's the most difficult part to me. Now you have to name that. And we can't just use angle M congruent to angle M, because there's two different pieces of angle M. So if I used angle LMN, how would I name the second angle? Good. Was that you, Asia? So if I used LMN the first time, you would use PMO. Good job. Is it okay that, like, I didn't go in order right here? Like, A's not in the middle? It's okay. As long as you know side, angle, side. Side, angle, side. Say by SAS. Now, this right here, it goes last, right? So triangle LMN is congruent to triangle PMO. Parker, before you pack up, let me give you something. Okay, I'm just going to tell you now, we are not going to finish this whole note taker today. We're going to do one more, okay? One more little slide. Okay. Okay, what's the next shortcut we're doing? ASA, angle, side, angle. Okay, how many steps am I going to take up with this given? 2. What does this symbol right here mean? Parallel, good. Bye, Parker. So I'm not given anything that says this is congruent to this. Not a single thing. I have to figure it all out. Now remember, we're wanting to use ASA. Here's what I do know. I know that PQ, a little arrow simplifies parallel. So PQ is parallel to RS, and then QR is parallel to PS. This does not mean they're congruent. This just means they're parallel. And I put 2 here to show that these two that both have 2 arrows, they're parallel to each other, and the ones that have 1, they're parallel to each other. Do you remember that day that we played with Skittles? Do you remember all of those relationships you learned? Kind of. In your city project? Okay, so these 2 lines are parallel. And this line right here is your transversal. Oh. Somebody in 3rd period, they literally said, this has included something from every single chapter. It's true. Okay? What is the relationship between this angle and this angle? Alternate interior. Yep, you see it? Opposite. They're alternate, and they're on the inside. Okay, what about this angle and this angle? Same thing. Are y'all writing this down? Are y'all drawing the pictures and the shapes? So, how many angles did we just figure out? 4 total, but how many sets? 2. And what are we using? What shortcut? Angle, side, angle. What are we missing? A side. Do you see one?
In the middle.
In the middle. Here we go. Good job. So we figured all of that out just knowing that there's 2 sets of parallel lines and a transversal. So now let's write it. Not bad. We got this. Okay, Emily, do you want to start with the one that has 1 rainbow or 2? 1. Okay, me too. Angle. How do I name this angle right here that has this 1 rainbow up top by Q? How do I name it? RQS. Good. So now it's congruent to this one down here. Well, I started at R. So where do I have to start now? At P. So it's congruent to PSQ. What's the reasoning? What was their relationship? Huh? Alternate interior, so that's exactly what we're going to use. That's the reason behind it. Okay, well, I know I'm going to do a second one the same exact way. It was used by alternate interior as well. Okay, I want you to try to name this second angle. I want you to try it. So if you're not confident, write it in pencil. You try to write how to name the second angles, the second set of angles. Madison, what did you write for the angles? Good. It's congruent to? Not SRQ, but RSQ. Good. Okay, so PQS is congruent to RSQ. The reason it's not SRQ is because that would be talking about this angle right here. S to R to Q, that's this angle. Okay, Logan, I've proved 2 angles. I'm missing my side. We already put our X on it, but how do I name this side that's congruent? What's this point up here, Logan? And what's this one down here? Good, so we name it QS. What's the reason, Grant? Why? Reflexive. Good. Now we're done. So by angle, side, angle, the sandwich is the side is sandwiched in between 2 angles. We can say triangle QPS is congruent to triangle SRQ. How'd you do? Decent? Guys, this is a process, okay? So don't think that those notes, we're not finishing them today. This packet of practice I'm giving you is not going to be finished in one day. Okay? It's a process, so keep up with everything.
I'm still eating both.
Sorry.
Okay, there is one thing I need you to fix on here. Okay, on number 4, look at 4. Look at 4. I want you to change this because we haven't gotten to this part yet. So cross out where it says MS is parallel to TR. Does everybody have one? Okay, so instead of proving that MS is congruent to TR, I want you to prove that triangle MAS is congruent to triangle TAR. Okay, now, because that changed what you are proving, you're not going to use all these boxes. Okay, so I think in third period we figured out that we use 6 on number 4. We use 6 boxes. Okay, so what I need you to do is I want you to finish 4 and 5. 4 and 5. Let me see it when you get done, please. Yes.